plus or minus Dalton's Law of Partial Pressure. A 1-liter flask is filled with 1.40 grams of argon at 25 degrees Celsius. A sample of ethane vapor is added to the same flask until the total pressure is 1.350 atm. What is the partial pressure of argon? What is the partial pressure of ethane? Well, let's see. I don't have enough information right away to get either the partial pressure of ethane or the partial pressure of argon. But let's look at what I do have. I have a volume. I have a mass of argon that I'm going to put up here because it's not going to come in useful at first. I've got a temperature that they insulted me with and put into put into Celsius instead of putting it into Kelvin right away, which is what they should have done if they were polite people. And then a total pressure, and note that this is the total pressure, 1.350 atm. Well, I have no idea how to solve this problem, but I've noticed they've given me one volume, one temperature, and one pressure. So the only thing I know how to do with one of everything is go to PivNerd, where I have enough information to figure out the number of moles total. So let's go ahead and solve for PivNerd and that number of moles total. So I've got 1.350 atm times a 1 liter volume equals a number of moles times 0.0821 liters atm moles Kelvin times a temperature Now let's solve for my number of moles. So I've got 1.350 times 1 divided by 0.0821 divided by 298 equals a number of moles of 1.350 divided by 0.0821 divided by 298 equals 0.05518 moles. And that's my total number of moles. So that's moles of argon plus moles of whatever the heck my other gas is, ethane. Well, I have enough information to get my moles of argon because they gave me my mass of argon right up here at the beginning. So all I have to do is 1 mole of argon, go to my periodic table, and and 39.948 grams of argon. So I multiply everything on top, divide through by every thing on the bottom, and I get 1.4 divided by 39.948, and I get 0.0350 moles of argon. So that's my number of moles of argon, so I can substitute it in down here. So I have 0.05518 moles equals 0.0350 moles of argon plus an unknown moles of ethane. So now I just have to subtract from both sides. 0.05518 minus 0.0350 equals my moles of ethane. And that gives me 0.020. All right. So that gives me my moles of ethane. All right, so I've got a number of moles of ethane, and I've got a moles of argon. What in the world does this have to do with Dalton's law of partial pressure? Well, to solve this one, they're wanting us to use the untraditional form of Dalton's law of partial pressure, and that's the one that states that the pressure of gas A is equal to the pressure total times the mole fraction of A. So to get our partial pressure of argon, it's going to be our total pressure times the mole fraction of argon, which would be our moles of argon divided by our number of moles total. So for this, it would be pressure of argon is equal to our total pressure, which is 1.350 atm, times our number of moles of argon, 0.0350 moles, divided by our total number of moles, that one right there, right? 0.05518 moles. And then we repeat this process again for ethane, where we take our, well, let me solve this. That gives me my partial pressure of argon, 1.350 times 0.035 divided by 0.05518 equals 0.856 atm. And then two ways to get that partial pressure of ethylene. I can do the whole mole fraction thing again, or partial pressure says that our pressure total equals the pressure of argon plus the pressure of our ethane. So we can just do a subtraction, 1.350 atm minus 0.856. And that gives me the partial pressure of my ethane as 0.494 atm. And that's all there is to it. Just a second, and I'm going to check my answer here because this has had so many interruptions for me. It's been hilarious. I've paused it every time I've been interrupted, but it's been like every 10 seconds. All right. And I'm going to assume that's correct because I've been interrupted for so long the computer has timed me out. Yes, that's correct. All right, that's good.